to introduce you to Professor David Greenfield. He's, I work at the University of Brighton, and he's now been part of the program for the visiting professor for the University of Brighton. Started off in the COVID area, COVID time. We had to do everything through Teams and things, which is rather interesting in that sense. David actually did his PhD at Brighton. Seems like a million years ago, in the late 90s. In fact, he just told me that he was involved with the research with the local authority in waste management, and 4 years of that, and led on to a huge contract of, was it 26 million pounds?
1.1 billion.
Sorry, 1.1 billion. A bit more than that, yeah.
Do noughts out.
Yes, indeed. And David has been involved in sustainable issues since 1998, and went on to circular economy around 2010, but now in his present role, about 15, 18 months ago.
Yes.
And without further ado, I'll stop talking. It's up to David.
Thank you very much, Deshi. And now I'm going to do the, let's transfer the technology so you can see my screen rather than Deshi's. Whilst we're doing that, thank you very much for the invitation to come and speak to you tonight. Thank you for all of you coming out on what looks to be a very cold January evening. Hopefully the technology will work. I want to talk to you about the circular economy, and just a little bit of a hands up. Well, I'm going to do audience participation. We're not going to be chatting or maybe speaking to each other. How many of you know circular economy inside out? Good. That's fine. The presentation can stand. So I got asked to come and talk to you about how we can engineer a circular economy. And thank you for the introduction, actually. You'll see at the bottom left-hand side, I've got a number of different titles, and I want to just explain that. First, I get bored very easily. I've been a visiting professor funded by the Royal Academy of Engineering, as I said, for 18 months. I actually worked in local government for 15 years, working at regional level, working at a national level, and running national programs of efficiency and carbon management back in the noughties. I left local government in 2008 and 2014, and set up my own research and innovation practice called SONECS. Ridiculous name. It's an acronym. It's Social, Environmental and Economic Solutions. Only an academic can come up with that. That is, of course, the definition of sustainable development. So I've been looking at really innovative research in the sustainability space since 2014. One of the projects that came out of that was something called Tech-Takeback. Now, those of you that live in Brighton and Hove might have heard of Tech-Takeback. We run a collection service for end-of-life electronics to try and get them reused and back into local charities. I've got a little slide later. And that came about just from a passion for seeing something that was horrendously being wasted. We wanted to turn the corner on that, so I'll talk to you about Tech-Takeback. As if I wasn't busy enough, in September we launched the UK's first circular economy venture studio. 4 of us scouring the UK for startups to try and invest money and experience into the development of the organisations. And we've just gone through our first funding raised £500,000. That's going to go into new businesses, one of which is a graduate of Sussex University, Lucy Hughes, who created Marine Tech. And then for my sins, I'm also the Vice President of the Circular Economy Club and Circular Economy Institute, both of which are international networks, both volunteer roles, and we provide training globally online, and we have 280 clubs around the world run by volunteers trying to get circular economy embedded in the individual local areas that the clubs are running. So that's a little bit about me, and I quite like materials, waste management, life cycle, everything circular economy. So I'm going to talk to you about some of the drivers, why I think we've got drivers for change, some of the solutions and where circular economy fits in. I've put in a little bit about government and local government policy interventions, mainly because many people aren't aware of some of the really good stuff that's going on. Then start looking at life cycle stuff, and case studies, and then a few business model aspects, and then questions. From a very practical perspective, I'm more than happy if any of you want to ask any questions while I'm going through. If you don't want to, that's absolutely fine. And then we'll close, and I think we've got until midnight. Right, okay. So, I just want to start off with a little bit of a driver. So this is a quote from somebody that you'll know well, which I think really highlights some of the challenges that we've got in 21st century global planetary thinking. This quote really highlights two things. Natural resources, something that we don't very often consider properly, and then the prosperity that should be handed down to children and our future generations. Some of you might know this quote. Any of you hazard a guess who this quote was from? Theodore Roosevelt in 1907. I think it's quite a powerful quote. It really highlights what we as the human race should be thinking about in terms of how we manage the planet, but how we also manage the future generations. And I've got two statistics for you, both of which I hope will blow your minds. This one in particular, it's 8 years old now, it's 23. 75% of the infrastructure that we place on this planet by 2050 has yet to be built. Now that was 8 years ago. If you look at that the other way around, essentially over the next 27 years, we're going to treble the amount of infrastructure on this planet. That's housing, that's officing, that's roads, that's energy generation. A large majority of that is not going to be in Europe. A lot of it is going to be outside of Europe. But the amount of resources, the amount of material, the amount of energy, the amount of water that is going to be used to actually build that, let alone run it, is insane. And when we talk about running it, this statistic is also really powerful. 80% of all of the environmental impact of any system, any product, is designed in the beginning. So if we get the design of this 75% of infrastructure wrong, we are leaving a legacy of significantly reduced resources, energy, etc. So we do need change, and we need to think about our consumption habits. I love this diagram just because it's got lots of nice pictures on it. But if we take the telephone, just about reached that, which is good. In 1900, this is for American households, roughly 5% of American households had a telephone. We follow the dotted line all the way through to 2005. By 2005, 97% had a landline telephone. That's pretty good. We take the cell phone. 0 in 1980-ish. Within 15 years, the same proportion of households had a cell phone. The rate of consumption, if you look at the VCR, is even steeper. The internet, computer, our adoption of the new technologies and consumption of those technologies is significantly greater than it was 50, 60, 100 years ago. So as a population, we're buying more, we're using more, and as we're growing as a population, that number is significantly increasing. We also have some challenges about how we actually design and engineer some of these materials. If we look at the natural world on the left-hand side and our food, you can see that a lot of the products that we use on a day-to-day basis are long-lasting. Not all of them. Pretty much all of the ones that we have created from natural materials have got short shelf lives. But if you look at a lot of the natural foods, they've got very, very long life cycles. We look at some of the tech that has been evolving over the last 30 years, 40 years, you can see that the earlier the tech, the longer the lifespan. So the bigger the blue bar, the longer the lifespan. There was a little bit of a blip in the 2060s with the PlayStation 3 and the Wii. But we're designing things to last nowhere near as long as we could. Again, another American slide. Again, this is a really interesting one, and I'm talking to you about engineering. It's a very loose definition of engineering. If we look in the 1960s, 95% of apparel, clothing, was made in the States. A normal household would buy 25 items a year and spend 10% of their annual income on those 25 items. Fast forward to 2010, they're buying 70 items with only 3.5% of their annual income, and only 3.5% of it was made in the US. And all the while, there's only a 15% recycling rate. We look at the resources, the energy, all of the engineering that sits behind this whole sector, just to throw away a huge number of items and make a load of items that don't last for very long. I'm sure many of you will have worked with critical raw materials. Apologies, the slide's not as clear as it should be. It looks a lot better on my small screen. Again, looking at some of the electronics that we use on a day-to-day basis. Most of these items are made using critical raw materials within them. And in particular, you can see some of those on the end: gold, copper, gallium, etc. These are things that, over the next decade, the demand will triple, potentially. So again, a lot of the drivers for what I'm hopefully going to talk to you about in terms of circular economy are around materials, about resource consumption, and the lack of availability of many of these into the future. But it's also the implications of some of the way that we make things. So I talked to you about planned obsolescence. I've shown you some of the materials. This is a landfill site in Ghana called Agabloshi. It's the largest waste electrical and electronic dump in the world. People live on this landfill site trying to recover raw materials. I could have shown you a little video for 2.5 minutes, but I've decided not to on this one. This picture is quite powerful on its own. These kids will normally be breaking up TVs, breaking up electronic items to try and recover the copper, to try and recover the aluminium, to sell it so they can go and take it back to their family. This has been identified as one of the most polluted places on this planet, all because people are trying to get critical raw materials out of our wasted electronics. That's one of the implications of the society that we're currently living in, which is linear. We take stuff out of the ground, we make stuff, we use it, and then we throw it away. And in many cases, we do not think about the end of life. What we're also starting to see is carbon. Carbon entering the mix as a driver for change. Some of you may have heard of Zero Waste Scotland. They've been pioneers in looking at carbon accounting and looking at how carbon is important to the decisions we make on different materials. So you can see on the left-hand side, I've got a nice little table with different waste materials. And then we've got, essentially, I'm not going to take you through the scope 1, scope 2, 3 definitions, but essentially, this column is the amount of carbon that is generated, CO2, that's generated during the manufacture, operation and delivery of that particular waste stream. This is the benefit or disadvantage of recycling that material. That's the disadvantage or advantage of incinerating it, and then landfill. So if we look at individual materials that we use on a very regular basis, so I've got batteries there as an example. 12 tonnes of carbon, CO2, are generated to create 1 tonne of battery waste. Now, that's the life cycle of those items. Now, if I take that green arrow away, you'll see that if you recycle it, you save half a tonne of carbon. So the net carbon output of a tonne of batteries is still 11.6 tonnes of carbon. And that's not including all the chemicals and the material and the metals that are in there. We look at metallic waste, similar sorts of number. And if we look at textiles, for every tonne of textiles, there's probably around a tonne of textiles in this room. If all of it was to be wasted today, there'd be 20 tonnes of carbon dioxide has been used to generate that. And when we recycle it, if we can recycle it, we're saving 5 tonnes. So, many people will be saying, oh, recycling is the right thing to do because we're saving 5 tonnes of carbon, without thinking about the full life cycle of that individual material. So a lot of what I'm trying to focus on is how we can start thinking from a material by material perspective, not just a systems perspective. So that's some of the drivers. I want to talk to you about a solution. You probably guessed what my definition of the solution is, hopefully, circular economy. But we're in a stage where we have to do less talk. We definitely have to get on with more action. So if this works, I'm going to just show you a quick little video from the Ellen MacArthur Foundation. I don't know if any of you have heard of the Ellen MacArthur Foundation. This is a really nice overview of what circular economy is. I've used it with a lot of the students at University of Brighton, and I don't think we've got sound. Let me just see if I can get the sound on. I'll narrate it myself. In fact, if we haven't got the sound, I won't narrate it at all. Really, very much what the Ellen MacArthur Foundation is trying to highlight through this video, which you test the sound, is that we currently live in a linear society where we take stuff out of the ground, we make stuff, we use it, and then we throw it away. Now, what we should be doing is starting to think of it from a circular perspective. How can we respect the resources? How can we respect the materials? How can we respect the energy and the water, and try and make them as efficient and effective as possible? And there's been 5 circular economy business models identified. I'm going to take you through each of these, just to give you an idea of some of the circular economy solutions. So if we start with circular supplies, how can we take some of the things that we're currently utilising on a day-to-day basis, use renewable energy for them, use bio-based materials instead of fossil-based, and think about the life cycle and design of those items to make sure that they're recyclable at the end of their life. I've got some examples for you in a minute, and I'll go through those in a minute. That's very much at the front end of circular economy, looking at how we can design in solutions. And that's where the role of the engineer is really crucial. The materials that are being used, the design of the engineered solution, to try and think about what happens to it at the end of its life. To think about the resource consumption during the manufacturing phase and then the use phase. Engineering will fit through all 5 of these different business models at different points in a product or a service's lifetime. And I think that's the really key thing. This isn't about just going, okay, we're going to build something brand new. We have to think from a circular economy perspective. Yes, you do need to think from a circular economy perspective when you're building something brand new, but you have to think about everything else as well. Perfect example of that is resource recovery. How do we recover the useful resources out of the materials or byproducts or waste at the end of the life? There are many, many, many materials, and I'll probably look around the room and go, my coffee cup. I think this is a veg wrap, which is fine. This can be composted. I have this really bad habit of going around and looking at items and going, okay, is this fully compostable? I'm going to take it that it is. However, many of the cups like this have got a very thin plastic lining in, which means they can't be composted because the plastic lining, which is designed for food safety, very sensible thing to do, means that the rest of the raw materials can't be recycled. So this comes back down to how can you recover those useful resources? And this is where waste management comes into play. This is where design for end-of-life solutions comes into play. And also, very importantly, understanding what materials are actually in things. We can look around the room and go, these are nice bits of timber. I'm just looking at them, making sure they've got rings on them, and they have. But I'm not an expert in timber. I don't know what material it is. It could be a pine. I would hope it be something softwood like that. When this lecture theatre gets disassembled, what happens to all of this? What is the material? Has it been varnished, and does that mean you can't do anything with it properly? The desks you're all sitting at are MDF. That's plywood, potentially. The seats you're all sitting on are all textiles, which I could probably guarantee that at the end of the life will get cut up and shredded and possibly burned. If we look at the carbon that's gone into different creation of these items, is that the right thing for the material usage and the resource usage? So resource recovery is really important in terms of understanding what resources we should capture and which we shouldn't. And that's just as important. We've then got, as the third business model, product life extension. This is probably the simplest one for everybody to get their heads around. How many of you own a classic car? Excellent. You're extending the life of resources. That's a really simple example, but many of you will have mobile phones which are 5, 6 years old. Again, that's extending the life. How many of you actually get your electronic or your physical items repaired? Or repair them yourselves? That's something that has been lost in the last 20 or 30 years. And we are in a very throwaway society that it's cheap enough to buy something to avoid repairing it, and in many cases it's more expensive to repair than it is to buy something new. So we've got the wrong drivers. But again, by designing new products and engineering solutions so that we can extend the life cycle is really important. And that also means understanding the actual usage of those items and how efficiently we can make them be used. The fourth business model is sharing. A relatively simple premise. How can we actually understand what materials and resources we've got and share them with others? I'll show you some examples that are local and demonstrate how easy this is. And then the fifth business model is how can we move away from ownership? How can we move to product as a service? Thereby actually making sure that we don't get to a point of throwing something away because we're actually renting or leasing a particular service or item. Now from an engineering perspective, the business models are really important, but the technologies are just important. And circular economy as an entity, and let's call it an entity, is utilising all of the sorts of things that are coming up in terms of how engineering can be utilised in the future. Internet of Things, big data, blockchain, RFIDs to try and track materials. Robotics, 3D printing, energy storage and harvesting. All of these are engineering solutions that actually contribute to supporting the delivery of these business models. Probably the area I haven't talked about too much today is the biotechnology, and that's one of the more exciting and fastest growing areas. How can we go back to utilising nature as a way of creating solutions? I've got some examples, but bioenergy, bio-based materials. I was looking, I realised I didn't bring my bag in, I could have brought you some props. Hydroponics and aeroponics, there's some really exciting solutions out there. And again, all of this is hopefully being delivered by engineers. So, these are the 5 business models and these are the 3 disruptive technologies. And from my perspective, some of you have already commented on my little badge here. Any of you know what this badge might be?
I've got one.
Excellent. Do you want to tell everyone?
The Sustainable Development Goals. You are the Sustainable Development.
Indeed. So, Sustainable Development Goals, if you're not aware, are 17 goals that have been put in place with sub-targets to try and look at how we can actually change the planet. Circular economy business models are one of the solutions to delivering those goals. And they're complementary. This is a solution rather than a driver in many cases. This can provide the answer to some of the challenges that we've got. Can't provide all of them, but it's another tool in the toolbox to try and get the UN Sustainable Development Goals. And it's being embraced very quickly and quite significantly by government and local government. And just to give you an idea of the origins, some of you will have heard of Professor Walter Starr. Any of you heard of Professor Walter Starr? He's an economist, Swiss economist, who in the 70s, late 70s, came up with cradle to grave principles, and was then followed by Michael Braungart and Will McDonough, who came up with Cradle to Cradle book in the late 90s. They were talking about loops of systems, loops of materials, how things are looping around the cycle. A relatively, let's say, niche product, which niche couple of books that people got behind. And it wasn't really until 2010 when Ellen MacArthur, she did that in 2007, she sailed around the world, came back and went, we are the most wasteful society on this planet. We use stuff, don't think about it. She lived for, 200 days on a boat with very, very few resources, came back and went, oh my God. Set up the Ellen MacArthur Foundation and took Michael and Will and Walter and a number of others and came up with the concept of the circular economy, which had been badged in Japan as well, slightly differently. But in Europe in particular, this is where it first started to get traction. So when Deshi said, I've been working in circular economy for 13 years, I was at the first Ellen MacArthur Foundation conference, which was 2010, where they launched a report. Since then, we've had things like the McKinsey report, which was a very, very powerful document that resonated particularly at the European level, which has suggested that adopting a circular economy in the European society could give you somewhere in the region of 5 to 20 billion pounds worth of economic benefit. 2012, Circular Economy Club was also formed. And then in 2015, the European Union put the Circular Economy package in. Now, if you look at the start of the Ellen MacArthur Foundation, that's 5 years between the concept of the circular economy being fully highlighted in the European Directive. 2018, the UK adopted the 25-year environmental plan and put in place the UK waste and resources strategy, both of which were actually quite ambitious for the UK. This is the strategy. I saw a draft version of this before it got published. Didn't have the words resources in and didn't mention circular economy at all in it. It was very traditional, how do we manage waste. But this first bullet point, preserving our stock of material resources by minimising waste, promoting resource efficiency and moving towards a circular economy, is a really powerful statement from government to say this is what they want to do. Whether they've done it is another matter. But having that in black and white and red has been really important. They're also highlighting that they want to reduce the amount of damage to the natural environment. And alongside that, the resource strategy came out of the 25-year environmental plan. They've got these 6 key strategic indicators. So resource productivity, what the raw material consumption is, greenhouse gases, carbon footprint, global greenhouse gas, domestic greenhouse gas, waste production, recycling, landfilling, and waste crime. This covers a large proportion of what the circular economy solutions can deliver. They can start to reduce the amount of waste going to landfill. They can increase the amount being recycled. They can reduce the amount of waste being produced. They can reduce the amount of greenhouse gases being produced and emitted. And they can actually improve the resource productivity. So from a circular economy point of view, this is where the government are coming from, going, actually circular economy is a way of delivering some of the solutions to meet some of these indicators. Now this has been adopted by many cities around the world. At the moment I think we're up to about 75 cities. I'm going to show you 2, both local and then a European one. London actually has been at the forefront of the circular economy for about 7 to 8 years now. London Waste Recycling Board, which is now called London, published its circular economy route map in 2018. And this is an extract from it in terms of how to look at the built environment. These are the commitments that they've asked people to use. Minimise the quantities of materials used, minimise the quantities of other resources, specify and source materials that are responsible and sustainable, design for longevity, adaptability and flexibility, design out construction, demolition, excavation and municipal waste from arising, manage demolition, manage excavation. These are the things that are asking developers to do in London as part of new developments, but also as part of retrofit. And they've got some nice decision trees that are in there. All developments should design for disassembly. That's a really, really important one. Going back to that first figure I showed you, the 75% of infrastructure has yet to be built, and 80% of the design of the environmental impact is designed in. If we've got new developments being designed for disassembly, that means you can take apart this building. You can say that that's a nice bit of pine that has got the potential for reuse, because it will have an RFID chip on it that tells you that in 25 years' time. This is a piece of work we did for the London Borough Tower Hamlets that was published in 2021, looking at the design of new buildings, how we engineer solutions into new buildings to affect behaviour change. Now, one of the biggest problems with a lot of tower blocks across the world is they normally have very low recycling rates during the operational lifetime of the buildings because they haven't been designed for that use. They've been designed so you can get water, you can get your electricity, and you can get up and down the stairs, and if you're lucky, the lift works. Most of them go, yeah, okay, as long as we've got a bin in the kitchen and we've got somewhere to collect it all at the bottom, it's fine. You look at that over 50 years, you look at that over 100 people living in that building, the amount of resources that flow through that system on an annual basis is huge. So we worked with the planners, the waste management companies, the council to create this decision tree for new builds in London. I'm not going to ask you to guess the acronyms, it's very niche, but essentially we came up with a solution that if there's a development larger than 50 units, 50 properties, then it has to have an AWCS, which is an automated waste collection system, which is essentially a vacuum system for 3 streams of material. That's now in planning law in London Borough of Tower Hamlets, which means that developers have to think about how we can actually capture those materials during the operational lifetime of the building. But it's not just London. Brighton have done quite a bit. Just out of interest, any of you know that Brighton has got a circular economy route map? One of you? Any of you know that Brighton and Hove has got a circular economy action plan? No. That's the problem. The circular economy route map was launched in 2021 and has some really ambitious, I'm not going to say targets, aims. Reduce consumption of primary raw materials in the city by 50% in the place of secondary raw materials. Just think about that as a really practical solution. All of the new builds that are coming on, we missed, unfortunately, the Brighton University there, but all of the new builds after that should be thinking about how we can reduce resource consumption. Yes, we want to hit a 50% recycling rate for municipal waste, which means the commercial sector as well. Brighton and Hove have already signed up to having a net zero carbon city by 2030. And they want to generate £100 million worth of activity within the city. This one for me is probably the most exciting, which makes me sound really nerdy. It also does help that I wrote that one. But by 2035, the council, as a public procurer, is making sure that 75% of their public sector spend will be on circular economy products and services, and that 50% of them will be with local suppliers. Doing 2 things. Shifting to circular economy through active engagement, and then also looking to the local supply chain.
Can I interrupt at this stage?
Certainly.
These are wonderful aims. Are you going to come to the teeth of the real incentives? For example, that top one, reduce consumption by 50%. Sounds great, but why should I do it? It's going to cost me money to try and things up and other. Nice aim, but...
I think this is where, if we look at this is now this will be part of the planning rules for Brighton and Hove City Council, and it is for Tower Hamlets, and it's starting to be for London, and we're seeing this across many different cities. But the policy drivers are essentially the soft teeth. There is a business case that sits behind it. I'm going to take you through some of those in a minute. But what we're starting to see is many cities, many regional and national governments starting to use some of their activities, their day-to-day policy making, to actually start to shift towards a circular economy. Now, that may not be the, right, you are going to do this, and this is why you're going to do it. But what we are starting to see is a huge amount of construction companies, engineering companies starting to embrace this because they can see it from the resource productivity perspective, they can see it from the material scarcity perspective, they can see it from the reduction in energy usage. And we're starting to see a huge shift in the mindset of many organisations that circular economy is a way to be much more efficient, be much more embracing of the climate change challenge, and also, more importantly, what we're starting to see with many of the new workers going out of university is that they want to be involved in a business which is sustainable. And we're seeing record number of people going to organisations that have sustainability credentials, rather than just borrowing the money. I was lucky enough, probably about 10 months ago, to do a panel discussion up in London with 7 startup companies. They're all turning over £5 million per year now. And we talked to them about what their drivers were. And all 7 of them avoided anything to do with money. It was all about planet. It was all about sustainability. It was all about leaving a legacy for the future. So what I'm trying to highlight to you today is that there is some major drivers for us shifting our current model of taking stuff out of the ground, making stuff, wasting it, and moving to a more resource-efficient circular model. Government, local government, regional government are getting behind that message. It's inevitable that this is going to come in, and is already coming in, and that some of the targets are going to mean that people have to change. So if we go back to the London example, new developments have to prove how they're becoming circular now. Doesn't help the 95% of the existing infrastructure, but once we've started getting those organisations to make that change now, they're going to continue that, and then they're going to start looking at retrofits.
Can I ask a question?
So,
Does that apply just for completely new builds?
yes.
Or for like refurbishment of an existing build?
In London, it's been designed specifically for new builds, but they are now trying to use the same policy for retrofit. It's far more difficult for retrofit. What we are seeing, and I could give you quite a long lecture on construction and circular economy, is that there is a lot more circular retrofit being undertaken. So rather than knocking down a building, actually looking at the superstructure and going, if we knock it down, we lose all the concrete, all the steel, all the energy that's gone into that. How can we adapt to that building? There's a lot of examples of that happening. We're not as good in the UK as particularly Holland and France, but we're getting better. And this is, again, apologies for the lack of clarity. This is from Amsterdam, where they've looked at the system of the city from a material perspective and started looking at the different material streams, the plastics, the woods, the concrete, how they can go about reusing them, how they can separate them at a demolition and deconstruction stage, how they can process. And they want to see the resources in the city utilised within the city for future developments as well as existing developments.
Just wanted to query your thoughts on looking at and getting the number of imported products into the UK which will need to follow the code. Where at the moment, I'm just wondering what that policing policy is and how active is it, and are people standing to attention and saying, yes, we're going to go down that road?
I think that's a really important question to ask. What is the source of a lot of the materials that we use? There has been some huge amounts of effort gone into trying to map the flow of materials into the UK. I've got an example, I think, in a minute. Yes, the next slide, actually, which I'll come to that now. This is a piece of work we did in the West Midlands, the West Midlands Circular Economy Route Map, where between 2020 and 2022, we did a review of the West Midlands and the flow of materials into and out of the West Midlands. So this is a Sankey diagram of the West Midlands, looking at the inputs on the left-hand side, natural resources, minerals, water, coal, oil, gas, etc. The utilisation of the sectors of those materials, and then the outputs. This is the high-level one, without any of the numbers in, but it gives you an idea of the quantities in terms of percentages through the width of the diagrams and where they end up. This diagram was used to actually build a policy framework for the West Midlands, which is now focusing on 3 specific areas of investments: battery technology, construction and moving to a circular economy, construction model, and food generation and waste. And that was all driven off this Sankey diagram of all of the inputs to the region versus all of the outputs. Can I tell you exactly where all the water came from? No. But we know it's coming into the area, and I think this is one of our biggest challenges. At a regional level, at a national level, the data is not good enough to be able to tell where all of these resources come from. But we do know, in many cases, what it is. It's just not the origin.
The genesis of the question was really based on some of the research I was doing for 5G, when my customers were looking at Huawei products. And it occurred to me that we never really thought about the origin of the product and what was in the product that might be harmful to us or disadvantageous to us in terms of control, management, and so on and so forth. So that was really where my thought was, and it's something that I'm building into my new work.
Oh, that's brilliant that you are. I think if we take electronics as a perfect example, and we're going back to critical raw materials, it is fair to say that in many cases the Chinese have a global manipulation of many of the materials, and that we're completely reliant on them getting us materials. We also have that with the Japanese, and the Asian market in particular has got a huge number of the raw materials that we rely on very much every day. And that actually, we're still seeing the effect of the Fukushima disaster 4 years ago now. The cost of second-hand vehicles is still very, very high because it's still very difficult to get hold of electronic chips, because one of the major manufacturers was put out of action for 18 months at Fukushima because of the disaster. So resource scarcity and resource quantification and ownership is only going to get more challenging as we go through. From my perspective, what I'd love to see in the UK is a resource department that is actually starting to interrogate the materials that are generated and used and disposed of in the UK, so that we can start capturing and giving ourselves some protection for the future, and then actually also building solutions in the UK. As I was coming over here, I just heard that one of the largest battery manufacturers in West Midlands has just gone into administration today. That means that, let's have a look over the next 20 years. How many new electric cars can we build? And have we just lost a manufacturing hub that could provide raw materials and energy and everything into the motor manufacturing sector? It's going to be offshore, and it will mean that we're then reliant on somebody else for some of the resources that we use. So it's one of those scary aspects that we're very reliant on our relationships with other countries to be able to continue to have the lifestyle that we may want moving forward. And if we don't think about it now and start designing it and understanding that resource flow, that life cycle of the material, we're going to be potentially in the future much more reliant on other countries.
Just come back to one of your bullet points on sharing. I mean, is there a philosophy now that the Western world is got an agenda that it will concede that it really does need to share more?
I think that's a lecture of its own. I think that is a really interesting point. I would hazard a guess, just from the many things that we've seen from Ukraine and from Russia in the last year, that much as many of central governments in the West might say that might be something we want to move towards, there is still a huge scepticism as to whether or not that's achievable. And I think it's probably an inherent challenge that there has to be some form of protectivism. But I think in many cases there's equally a lot of lack of understanding of the problem at a central government level at this stage. They have a resource strategy, but it's done by one department who the Treasury probably looking at. We'll get to a point where it becomes more important, I suspect. It's an interesting one. I was chair of the Institution of Civil Engineers Resource Management Panel for a decade. Left 2 years ago, last year. And for the whole of that time, we were calling on government to have a resource department to start look at resources in the UK and how we can capture them. Okay. I'm going to move more into a little bit of life cycle. We've done quite a bit of that. And then just give you some case studies. And then I'm going to open up to some questions. I put this diagram on because it's really simple. It's really simple. I use this with students a lot to highlight that it doesn't actually matter what sector we're talking about. Pretty much anything in this room has gone through this process. It's been designed, the materials used to make it have been identified, there's been a construction method, there's use phase, and there's an end of life phase. And if we get this life cycle of stuff and start putting in place circular economy solutions, we end up with slightly different designed things. This is a really nice diagram which highlights that it's not as simple as that previous diagram. This is a diagram called Building in Layers, and it identifies 5 different layers in a building. The stuff, the desks, the chairs, which have normally got a up to 3-year life cycle. The space, so coming back to this, 3 to 7 years. The services, the electricity, the gas, the water, 7 to 15 years design life. The skin, many of the buildings we've seen will just have 15 to up to 50 years life cycle. And then the actual structure, so the bricks and mortar, the concrete, steel, normally has somewhere in the region of 60 to 120 years. Depending on what type of building you're looking at, that can be as low as 20. Those of you that are in Brighton and Hove, you know when the Annex building was built in the centre of Brighton, I think it was, what, 77? It lasted 33 years. There's buildings which have gone down much sooner than that. So if we look at, again, the life cycle, we've got the use, we've got the assembly, we've got disassembly. There'll be different solutions for different parts of the building envelope. And that again comes back down to when you're designing something, you need to start thinking about different utilisations, different layers. I suspect that, and we can see from here, most of the electrics will be behind this. You need to upgrade the electrics. Most of this wall will have to come off. What do you do with most of this wall? That will probably get binned because it hasn't been designed to be disassembled. So this is where for architects, for designers, for construction people, start getting into that thinking of looking at how individual items, individual solutions affect individual, the next part of the life cycle. And then you've got, from my perspective, in the construction phase, 5 different stages. So you've got the design phase, the manufacture, supply, construction, in use, and end of life phase. This is a matrix I created for an article in 2017, I think it was, looking at what the circular economy solutions are in different phases of the construction life cycle. So I won't go through all of them, but it just gives you an idea of looking at the life cycle stage and then looking at slightly different solutions based on the stage of that life cycle. A lot of people say, oh, isn't circular economy just about those 5 business models you talked about? Yes, it is, but you need to apply them to the right design phase or the right life cycle phase. And as we've said, and I've talked to you about these 5 different business models, I'm not going to go through them again, but what I want to do is give you some examples. give you some examples of solutions that I've seen and got involved in to just try and lift up why these are potentially the right solutions. So this is a little bit more of a longer definition, but ambition of circular to keep resources in circulation for as long as possible, replace scarce resources, fully renewable, recyclable, biodegradable inputs. So we'll start off with a nice little wind tree. This is a French engineer that created this. Each of those vanes are up to 2 meters high. Sorry, up to 1 meter high. This has been designed to capture wind energy in urban areas where the wind speed is quite low. So this only works up to 5 meters per second wind speed, and will generate enough energy for 83% of the electrical consumption of a French household, excluding heating. It's quirky. It's really interesting. It's very cathartic to watch, actually. It's a really interesting way of thinking about how we generate renewable energy in more difficult to capture energy areas. And talking of engineering, any of you seen the solar roadway? What way? Again, another French activity. That is the microscopically thin solar panel, which is laid onto a very, very good road. Probably why we haven't got any in the UK. And then covered with, and it's not a particularly nice resin, I'll go over that. But essentially, 90% of the time the road surface is facing the sky and is empty. So what better place to capture energy than an existing asset? So it's not cheap. I think it's something like £300,000 per kilometre to build. But the energy generation is really quite good. We tried to get this over to London in 2017. Couldn't get anybody to fund it. They're still trying to get it over here. But they've got about, I think, 40 or 50 kilometres of this in Europe. And possibly it's working quite nicely because there's still a lot more sun over there in many places. But it's a really nice way of, again, looking at existing assets, the road network, and going, what else can we get from that existing asset? Another example of that, in the London Underground, in the disused tunnels, these guys have opened up. They're using hydroponics, they're using LED lighting to create underground farms that can grow very consistent, very high quality food. Keeping it local, using significantly less resources than if this was done in a traditional greenhouse, and utilising abandoned space. Picks up 3 or 4 different circular economy aspects. Some of you will have heard of these guys. Any of you watched the Earthshot Prize this year? They won. These were one of 4 organisations globally that won one of the Earthshot Prizes. I've been working with them since 2016. It's an edible capsule that contains liquid. Made using seaweed, and normally when I do something like this we have a bowl of those which we give out to people, but they're very, very busy at the moment as a result of the Earthshot Prize, and we did an event with Ernest & Young just before Christmas, before they won the Earthshot, and they had porn star martinis in the nocturnals. But these were designed originally as a replacement for single-use plastic bottles, when actually what you need is to sate your thirst. Do you need a plastic bottle? No, you need to consume liquid. So they created it so it pops in your mouth and it dissolves and you can swallow it and there's no waste. Similar example, 21st century packaging solution. This is a plastic wine bottle, plastic, flat, so it will go through your letterbox. Made out of 100% recycled plastic and 100% recyclable. So all the labels and the cap are all recyclable as well. This was designed as a, actually people were sending bottles of wine by post at the beginning of the noughties. There was a lot of damages, there was a lot of returns. They went, you can create this. They created it. And then they realised the bigger picture, that as a packaging solution, you can get 12 bottles of wine in the same space as traditional 6 glass bottles. If any of you shop in Tesco's, as I did last week, there was a whole rack of these on the shelf at Tesco's. They have now manufactured over 3 million bottles and are being used by major wine companies around the world as a way of reducing the carbon footprint of the transportation of wine, far less breakages, and very quirky design as well. I got invited to BMW in Park Lane about 15 months ago to go and see their circular car. This was a concept car and has 5 very good things about it. That's made from 5 materials, that whole vehicle. What they wanted to do was to reduce the raw material usage. They also wanted to design it so that it was reusable. Now, some of you might think that looks like the Grand's lounge from the 1960s, but there is a specific engineering purpose for it. These little bits of ribbon you can actually pull, and that will disassemble the textiles, and then you can reassemble them. These little circles here are essentially the button that you press to disassemble something, so they're dotted around the car. It's a concept car, possibly won't make it to manufacture, but this is all recycled plastic, all recycled glass, all recycled rubber, all recycled textiles, and all recycled metals. Hasn't got an engine in it. If it did, it would be an electric engine. But as a concept car, it's really important. And possibly the bigger thing from an engineering point of view is that BMW have adopted a term called secondary first. So for their manufacturing in Germany now, they use secondary raw materials first. And if they can't get secondary raw materials, they have to go and get permission to get virgin raw materials for many of these items. So there's a lot going on there. Resource recovery is the second business model, trying to recover as many resources as possible. I put this on. Many of you will have seen the energy recovery facility in New Haven. Do you know the energy recovery facility in New Haven? Any of you? Yeah, any of you? At the time of building, this was the biggest engineering project in Europe. Trying to build a 28-metre deep excavation next to the river was significantly challenging. And the reason it was built that deep was to avoid the roof line being too high on the surrounding area. It now looks like that. 210,000 tonnes of household waste gets burnt there every year to capture enough energy to power around 45,000 households. The design's quite curious. On one hand, that is resource recovery. That is taking materials that are currently being thrown away and recovering energy. Is it the most efficient way of doing that? No. Is it a necessary thing at this moment in time? It still is, unfortunately, because we're not getting to the recycling rates and the recovery rates of materials at a household level that we should be. What we need to do is start thinking like these guys. Buy a bean. Some of you might have even bought these logs. These are available in Tesco's as well. and Sainsbury's and other leading supermarkets. They're taking coffee ground waste from many of the coffee chains that we now see and turning the husks into things like this coffee log, which can be burnt. It's low carbon burning, but they're also extracting a lot of the oils and are now starting to work with the oils. So they're taking that waste stream and looking at it from two different perspectives, how we can actually utilise it for something else and look at some of the compositional understanding of those individual materials. I mentioned Lisa Hughes. Any of you heard of Lisa Hughes? Sussex graduate from 2019. She won the James Dyson International Awards and the UK one. This is fish scale and red algae. It's a replacement for plastic film, fully compostable, made from waste products. She got something like 10.5 million views on YouTube, if that's how we should be defining success. She's spoken at the UN about this. Again, starting to think about resource recovery. We're in the business model resource recovery. How can we take a waste stream and do something special with it? How many of you at Brighton University? Just hands up. This isn't to get everybody else to throw. How many of you know about Brighton Waste House? A couple of you. This was the first permanent building in Europe made entirely out of waste. Now I say entirely out of waste, it's 90% waste. 90% post-construction waste. It's passive house standards. It is currently a engineering test bed. All of the walls are filled with different types of waste. So you've got everything from bicycle inner tubes. There's 500 inner tubes in one wall, and they're testing to see how good that is at preventing energy from being lost. It's 1.8 tonnes of denim. And they found a company in West Sussex which is importing jeans from China, cutting off the legs, turning them into shorts and getting rid of the bottom of the legs. They've got 1.8 tonnes of cut off denim. They've got 19,000 toothbrushes from Virgin Atlantic, because on all of the transatlantic flights they provide a toothbrush in a bag. 95% of them are never used, but because of health and safety they have to throw them away. So this is a living exhibit of how profligate we are with some of the things that we actually use. If you haven't been, I would recommend it. It's well worth a laugh. It's also well worth understanding some of the wasteful products that we have in there. A lot of VHS tapes in there. Now, I talked about the disruptive technologies. This is one of them. So there's a company called Recycli, which is using machine learning to now identify different plastic bottles at, this is real-time speed, to be able to separate them into different polymers. Now, traditionally this has been done by either hand or by infrared spectroscopy, but they're now doing it with machine learning. And there's 4 companies in the UK that are really focusing on this. A really good example of using disruptive technologies to be able to recover resources. Most of these materials would probably have been incinerated. They're now being recycled. Another one is a company called Bio, which I don't think I've got any sound on, so that's fine. Which means I'd have to narrate. So you have director and graduate from UCL. Essentially, they're using the simple organism called mycelium to create building products out of a natural material. As we haven't got the sound, I'm going to skip on a little bit, but you'll see in a second, they're creating 3 products. This is a lampshade made out of coffee grounds, orange peel, or hemp. They're also creating insulation boarding, hopefully we'll be here in a second, out of mycelium, and they're growing the insulation boarding on other waste products. There we go, there's a bit of the boarding. So these have been designed to be the same size as traditional plastic SONECS boards. These are carbon positive. They have exactly the same heat retention properties as SONECS. They're made from a waste product and they're grown. And at the end of their 30-year life cycle, they can be composted. I've got another video here, I think. Oh, there we go. Right, let's go on to the third business model. I said to you this is the one which is probably the most simple. I'm going to pick up what we do. So, any of you that are in Brighton and Hove, if you haven't used this service, you've got 2 options. We offer a doorstep collection for your end-of-life electricals. What we want to do, so we've set this up with an app called the ZeroNet, which means that you can tell us what items you have, and then we'll arrange a day to come and pick it up. We started this just at the end of lockdown, which was quite challenging. But most importantly, where you've got data bearing devices, everything is raised to government standards. As I said to a couple of you beforehand, we've now collected over 100,000 electrical items from Brighton and Hove residents. That's either through the app or through the shop that we have at the bottom of North Street. Some of you might have seen the shop. This is in partnership with Brighton and Hove City Council. It's an old live-in shop that has been empty for 2.5 years. And we're now selling to cover the costs of processing all of the items that we can reuse on a gift economy basis. So there's guide price. And a lot of the funding that comes from this will then support the charities that we provide bespoke built electronics to. So we've currently provided over 600 built laptops for digital inclusion charities, homeless charities, from devices that have been donated across the city, either from businesses or through individuals. And we are providing particularly this is financial crisis time, low-cost electrical options for many residents in the city. We also did it with a circular economy mindset. This is the second shop, so we've got the hub and the shop. The hub was a tapas bar that closed down in 2019 and was left for 2 years. That was what it looked like when I turned up there in November 2020. Yeah, November 2021. There were still bottles of wine that were open on the bar. This is what it looks like now. Very similar, a lot cleaner, and it's now a home workers cafe, so people can come down and use the desks, pay by the hour, get free teas and coffees. We also run events in there. And some of those events include disassembly, where we actually do corporate disassembly events now, where we'll take 30 or 40 computers, 20 people will come down and spend a couple of hours taking apart a laptop to be able to understand, firstly, how they're built and how they can be designed for much better disassembly, but also to understand some of the raw materials. Again, looking at extending the life. This is a really interesting website called Buy Me Once. They've tried to gather together all of the products that have been designed for long life. There's some really good things in there. They've got a pair of socks in there which they suggest have got a 10-year lifetime. They've got things like La Crusade. They've got all sorts of things which have got long lifetimes. If you're interested in this sort of thing, I'd definitely go and have a look at that. We've also got people like the Restart Project, who are based in London, who are very much pushing for the right for repair. We're currently working with them as Tech-Takeback to look at when we should repair something and when we should actually set it aside for scrapping and disassembly to recover the raw materials. And it's a multi-criteria assessment: historical value, functionality, economic value, social value, and environmental value are the 6 different criteria we're looking at. These guys are really pushing the concept of repair of items alongside the repair cafes. I'm sure many of you have heard of repair cafes. Yeah. Just in case you didn't know, this Saturday the repair cafe is happening at the Revalue Hub at the bottom of North Street on Saturday. Right, I'm going to skip through. We've got a couple of minutes left. Sharing platforms. Have you heard of Freegal? Websites, 4.3 million users across the UK. If you've got stuff you don't want, you can put it on here and people will come and get it off you for free. If you want something, you can ask for it, and if somebody's got it, they can give it to you free. It's a non-monetary sharing platform. There's 30,000 members in Brighton and Hove, so well worth looking at. If you like your food, 3 very good websites, stroke apps to go on. Too Good To Go, I use far too much. Essentially it was set up to help restaurants get rid of food at the end of the day that they would normally throw out. I've ran 2 conferences on Too Good To Go food, essentially going around to restaurants at the end of the day and signing up and grabbing things. You don't know what you're going to get, but that's part of the fun bit. This is work that's being done in Amsterdam to try and understand what resources are available and how they can be reused in different construction products. And then quickly move on to servitisation and start looking at how we move from consumption to leasing. This is a rental platform for clothing. So rather than everybody owning a high expensive item that they use once a year or once ever, you can share it. NUS in London pay for their lighting by the lumen. So rather than going and buying the bulbs, Philips provide all the lighting and they charge the NUS based on how many lumens they use per annum. Really helping them to think about how much they consume, but they can also identify who's using what, so it can be moved into maybe Big Brother, but it helps to highlight to individuals their consumption. And there's some of the big brands, as I said right at the beginning, some of the big brands are really embracing sector economy. Rolls-Royce engines for airplanes, pay by the mile. Michelin are starting to look at pay by the kilometre. Talked about NUS. All of the baggage that is done at the airports are done by number of items, pay per baggage. So this is us moving into the servitisation model, where we're paying for a service rather than paying to consume. Another local Brighton activity, Super Looper. For those of you who've got children or young children or grandchildren, this is a leasing service for child's clothes. And I'm going to leave you with one more video, which is the Library of Things. We've just opened the Library of Things at the Revalue shop at the bottom of North Street. High value, low use, personal items. Personal items being things like a tea urn or a drill or a sander. You can rent these on a short term for when you need them. Why do you all need to own a drill when actually if you've got one drill shared between 20 of you, you're getting the maximum life out of it, plus you get good quality items. If any of you do want to look at Library of Things, it's free until the end of March. Okay, so I'm going to conclude. I've gone a little bit over time. Apologies. So, how can we start thinking about climate change and the impact of climate change? Consider the end of the start. That's probably the most important thing. If you're looking from an engineering perspective, always think about what happens at the end. Understand that life cycle. Understand the resources what you consume, and as an individual, do what you can. Thank you for listening, and sorry for going on a bit too much. Hopefully that was interesting.
Thank you very much. We had a few questions during this session, so that's why it's gone on a little longer than normal. We can have a few more now, Mike.
I have a couple of questions, if you don't mind. First of all, you said on one of your slides you had a statement which said roughly value engineering minimise or something like that. Now, does that mean using value engineering to minimise something, or it means that way round? Because I got confused what it actually meant. And what is it in practice?
So value engineering is actually a term that is used in the construction industry, which is in many cases a complete and utter farce. So essentially, the builders will fit out a building, and then the new tenants will come in and do a value engineering piece, which essentially means that they can go in and have a look at all of the fixtures and fittings and say, we don't value that, and so we're going to engineer it out. So they replace a lot of it, and most of the brand new equipment that's been put in place is actually thrown away. So on that slide, it was very much around reducing the use of value engineering to try and prevent waste being generated. What should happen, and this is one of the major problems we have in the building sector, is there's a lot of speculative build, and the build is designed for sale, and then you end up with a tenant coming in and going, well, that's nice, I want the space, but I don't want the stuff, and so it all gets value engineered out. So the collaboration angle is most important.
Okay, thank you. Can I ask the second question?
Yes, please.
Second question was about lithium. You mentioned lithium and batteries and that kind of thing. I was first of all surprised that lithium wasn't in your list of critical materials from that. But what is the problem with lithium recycling? Is there a particular problem?
Yes, there is. I'll come back to the first point, which is I didn't put on the full list of critical raw materials. In electronics, there's 14 identified critical raw materials, and across many electronics, there's around 60 critical raw materials used. Some of them are critical from the perspective of they're absolutely necessary. Some of them are critical levels of scarcity. In terms of lithium, in many cases, it is recyclable, but it hasn't been designed to be recyclable. And that's the problem, in many cases. The consideration of what happens at the end of life is still not there from the design perspective. The lead acid batteries of old are actually relatively recyclable. They're not particularly environmentally beneficial, but they're relatively recyclable because of the way they've been designed. And they weren't designed to be reusable, it was just that's a quirk of how they were made. So many of these materials can be reused, can be recycled, and can be recycled back into what they're originally designed for, but they're not designed from that perspective. They're designed just to be a single use or a long-term use product that then at the end of life somebody else deals with it.
Thank you very much.
Do you think that in the sort of commercial business world, there's a misunderstanding about end of life for a material, for a product, and for a service? I find it sometimes very difficult to get through the finance people exactly what I mean by end of life.
Yes. Terminology is one of the key things. When I speak, I talk to you a lot about life cycle and end of life. When you're talking to a finance person, talk about whole life cost. That puts a very different spin on it for them because then rather than looking at the cost at the start of the project, and buildings are a really good example of this, cars are a really good example, the upfront cost is normally the highest point. In many cases, coming back to 80% of the designed-in environmental impact, the lifetime cost is higher than the capital cost up front. So if we start talking to the finance teams about whole life costing and looking at it across 20 years, they'll take a completely different perspective on two different products which might have very different capital purchase prices, but will actually have significantly lower operational life costs. The problem we've got with many organisations is they don't look that far ahead, and so they just look at the capital purchase cost, which is why we end up with a lot of short-term, low-value, cheap products, because we're not looking at that.
It's also about return on investment and the amortisation of the capital.
Indeed.
You know, there are certain structures that they seem to live by.
Yes, it's interesting. I've done this, or a similar version of this presentation for Brighton and Hove council officers. We did it for the procurement team, and there's an organisation called the Chartered Local Authority Procurement Officers organisation, and they have their own circular economy video, which I far more boring than many of these. But again, talking the same language, and the language that is used for different departments, different services is really critical. It might well be that it needs to be something completely different to that person.
It strikes me that education is a very important part of all this. Is there any evidence, or do you see any education being carried out in schools? Do they have circular economy written into the curriculum?
Not written into the curriculum. What we are starting to see, and we've just produced a circular economy video for Southend schools actually, from a European funded project on plastics. It's starting to permeate into the mindset of schools. It's not through official curriculum, but it's starting to get in there. Coming back to my role in the University of Brighton, my role is to try and embed circular economy across the curriculum in the University of Brighton engineering department. Whether or not I'm going to be entirely successful in that is another matter, but what I have been able to do, which is I think really encouraging, I think I'm now lecturing across 6 different specialisms, 9 different specialisms, 4 of which are in Detch's engineering school, but we're talking to architects, we're talking to planners, we're talking to environmental engineers, chemical engineers, mechanical engineers, aeronautic engineers, and that's really important that we start to help those specialists understand circular economy, because one bit I didn't mention today is that we need to have that connectivity so that the electrical engineers speak to the mechanical engineers and the mechanical engineers speak to the environmental engineers, and we have that community and cross-fertilisation of knowledge, because that's the only way we're going to be able to solve some of these fundamental problems. Right, I think I've taken you to the end.
All right, just a little question.
Yeah.
Going back to these doorstep collections for electrical,
Yes.
Do you collect things as big as fridges?
No.
No?
No.
It always strikes me fridges, one of the big areas crying out for life extension. We just throw them away when a tiny thing goes wrong because it's too expensive to repair.
Indeed. I agree. I think that we focused on small electricals for the simple fact that they are probably the most common.
Yeah.
Fridge recycling is actually very, very high. Fridge life extension is probably very low. So from going back to the agri-blotchy waste problems, in many cases the white goods, the fridges, the freezers, the washing machines, the tumble dryers, most of those are recycled because you can either have a manufacturer take back or you can take them to the house or waste site. If we look at all of the other small electricals, lamps, irons, toasters, kettles, laptops, all of those, many people still have at home, sitting in a cupboard, hoping that someday they might be useful. Or they go to the household waste site to be thrown away, or they go into a wee bin in the city. And all of those are shredded and a few materials are gathered. So the reason why we put in place the Tech-Takeback service is really to try and get reuse of many of those items. So if you go into our shop, you'll see items from 10 years old, 15 years old, that are working perfectly usable, might not be the most up-to-date style, may not be as efficient as a brand new item, but are affordable. And that's where the rub comes in, actually. That in many cases, for particularly white goods, the energy efficiency of the older devices is so low compared, so low compared to the energy efficiency of brand new ones, that selling a 15-year-old fridge to somebody will actually cost them more to run it than if they go and buy a new one. Whether or not it's 15 years or 20 years, it's debatable depending on the...
Lucky if you get 15.
Well, indeed. But I think, again, this is where it comes back down to there are multiple factors that you have to consider. So this multi-criteria assessment tool that we're doing is trying to look at that. And energy consumption of the product during its operational life is absolutely one of those.
So a good question on that. Is there a law, is there a plan to introduce a law to force the manufacturers to provide parts to allow the fixing of these items? Because I think that's the problem, that you can't find the part straight away.
Yeah, there is the right to repair law that came in last year. Coming back to the question you asked me about teeth, I think that law is probably one of the most, it's toothless. It's trying to do the right thing, but it's not succeeding. I think over the next 5 years we're going to see a lot more rigour come into that. That means that manufacturers do have to start providing this support. There is a very good example which highlights the farcical nature of it as it currently stands. Apple are taking part in the right to repair. I could go to Apple and ask for parts to repair one of the items that I own. And they say, yeah, of course you can have that. This is how much it's going to cost. Oh, by the way, you have to use a specialist tool, and you have to hire the specialist tool off us. And by the way, it's going to be 250 quid for us to ship it from America too. So it's not driving the right behaviours just yet. I think we are behind somewhere like France. France in particular are doing a huge amount to embed this in legislation so that manufacturers have to offer right to repair. That's going to trickle through potentially to us, whether or not it does because of Brexit, still to be determined. But if we get it happening in France and across the rest of Europe, it is definitely going to trickle in because the manufacturers will just take that as the norm and start to populate it across the thing. But it's a really challenging area at the moment. There's a demand from the public as well to start to repair things, and we're getting asked all the time whether or not we can repair things. Repair cafes are getting very, very busy and sought after, and we're starting to see repair cafes popping up all across the country. So I think there's a consumer demand, whether the manufacturers are in the same mindset at this moment in time, probably not.
Is there a worrying trend there that you're going to have people doing repairs who are not suitably qualified?
Yeah, that's one of the excuses that many manufacturers use to stop repairs. And it's a very valid concern in many cases. However, again, it comes back to the design. If manufacturers design things for repair, they should be able to design them so not a fully qualified person should be able to do it, but a hobbyist can do it, or somebody that is being supervised by somebody in a repair cafe.
I think, thank you very much. I think you should all... Sorry,
Would I like you to get copies of the slides, or are they going to be up on the web?
We can share the slides. What I won't do, some of the videos I've shown you,
No, that's fine.
I can't share.
No, it's just
I probably
getting
can.
information
It's on
back
YouTube.
in, yeah.
But there's, it's also on the camera,
Yeah.
on the video.
That video will be available on the website.
Oh, right,
Yeah,
okay.
yes, I think I sent you a 900 megabyte slide
Oh, okay.
deck. So we don't want to share that, but I'll do a condensed version.
Okay, that'll be great.